I have two case studies to talk to you about today in California. So one is property in Sacramento called Foothill Farms. Another is Sage Park, which is a property in Los Angeles. And at both of these properties, we did deep electrification retrofits. Or actually, we're in the midst of doing deep electrification retrofits at them. So they're present day. And my company, Carbon Zero Buildings, is a turnkey design build. Actually, you can go to the next slide. Turnkey design build general contractor. We're focused exclusively on California multifamily retrofits. We do electrification and efficiency, and primarily low income, but some market rate housing as well. And you can go to carbonzerobuild.com to learn more. Next slide, please. This is Foothill Farms property upgrade. So we did at this property in Sacramento, lighting, HVAC, water heating, electric vehicle charging, pool heat pump water heaters, and gas to electric dryer conversions. So we'll go into the project scope. So this is the scope of work that we executed for the customer. This is a typical kind of customer presentation that I would give. So 138 unit apartment complex. We converted their existing air conditioning over to heat pumps. We converted their existing gas water heater. So this is unitary. So every apartment unit has a gas water heater in a closet. And every apartment unit has a condenser on the roof for as an air conditioner. And so we replaced the water heater in the closet with a heat pump water heater, aerators, in-unit to LED lighting, which are oddly some of the things that customers get the most excited about. Like that's what the residents comment on. Oh, it's brighter in here, you know, and it's the simplest stuff. But it's kind of like a spoonful of sugar for the overall project. I mean, everything else is good too, but it just is a nice thing to incorporate. And then in the common area, their corridor systems we converted over to heat pumps. We did heat pump water heaters in common area. Common area LED lighting, heat pump pool and spa heaters, variable speed pool pumps, 16 electric dryer circuits, and 30 EV charging stations. So, and the next slide has the financials for the project. So it's a $2.6 million project. We were able to bring in $2.57 million in incentives, so the owner's contribution is $27,000 to do this project. It's an affordable housing property. And the incentives were pulled from LIWIP, the Low Income Weatherization Program, SMUD, which has its own electrification program, and the Clean Tech California program. And then we take payment of those incentives directly, so the owner only needs to pay the net. Because that's a major barrier too, is a lot of times like an owner needs to pay $2.5 million and then get it back later. Like most owners will say, no thanks, I can't do that, particularly affordable housing owners. So that's part of how we've structured ourselves to be able to make these projects happen. Next slide, please. So now I'll just go through kind of a slide per measure to give you a flavor of what these look like. So, you know, here is what we had previously on the rooftops. This is for the upgrading the in-unit AC to heat pump. So maybe before I go into, well, yeah, so I guess I can just go left to right. This is a condenser farm on the roof. So each unit has a condenser that's serving an indoor air conditioning unit. Here are the new condensers that we put in, Samsung Hilux. And then here is in the ceiling of the apartment unit, there's a indoor unit. Now this indoor unit is a challenging indoor unit, very common in California. First Co, it's probably the most common indoor unit we see in the ceiling. So it's got two sides to it. On this side, you've got this copper pipe, which you probably can't see because it's too small. That's actually has a pump attached to it that pulls water from the water tank in the closet and uses that as the source for heating. So it's taking 120, 130 degree water from the water tank, running it through a coil, and then it goes back at 100 or 110, back to the gas water heater, and then the gas water heater heats that back up. That same gas water heater is doing the domestic hot water work as well. So as you know, what heat pump water heaters don't really like, the Rheem heat pump water heaters, is doing that work of putting in small temperature lifts. Heat pump water heaters are much more efficient when you put in cold water and then you bring it up to full temperature. So that's really problematic for just going in and, like, if you just put a heat pump water heater in that closet, you're going to have a disaster. You won't meet domestic hot water loads. Maybe if we go to the next slide, maybe I'll go back and forth between these two. So this is that gas water heater in the closet here, and this gas water heater in the closet, the pipes come up out of the top for hot and cold, and then they split in the top of the closet here. If I had more zoomed in photo, you could see. But essentially that split is one side goes to domestic hot water, one goes up to the heating. So if you see that situation and you just put a heat pump water heater in here, well, this is a 40,000 BTU gas water heater. What's the compressor BTU rating on a heat pump water heater? Like 4,500. That's what a ream is. So you put in a 4,500 BTU water heater, you're just not going to meet heat load. So it's always something to be careful of. So we had been screening those projects out, but what we ended up doing is coming up with the solution where if we go back to the previous slide, you can see this unit, the Samsung Hilux. I learned about it AHR Expo the year before last. Fortuitously ended up sitting on the plane next to a Samsung engineer who was a friend of mine and heard about it. I was like, oh, this would be perfect for Foothill Farm. So, and many other properties in California. So basically what we do is we abandon the side of the, so the Samsung Hilux, I guess I should say, is a drop-in replacement to convert existing cooling-only heat pumps to full heat pumps. And you can reuse your refrigerant piping, which is really important for retrofits. And then you install the outdoor unit and a new control box up in here. And basically you take this side, which is the refrigerant side of that ceiling unit, and you convert it to a heating and cooling heat pump. So whereas previously it was doing cooling only and the heating was coming from taking that hot water from the tank, now we do heating and cooling. And then we abandon the side that used to pull water from the hot water storage tank. Now we put in a plain old heat pump water heater to do the domestic hot water side. Another important thing that we had to do is that the disconnects on the roof were only 20 amps, and the Samsung Hilux out of the box was like 22 amps on its MCA rating. So that was a problem. But Samsung you can field derate the unit in 5% increments, and it linearly derates the MCA as well as the tonnage. And it was more tonnage than we needed. They only had 1.5 ton existing units. We were putting in a 2-ton unit. So we just derated it down to 85%. So now we made it 85% of 2 tons is a 1.7 ton unit. And then it just snuck in under the MCA. And Samsung we talked to Samsung because we were concerned about the inspection process. They're like, we worked out a way to get new labels printed actually. So we put a new sticker on, matched the serial number, and they were okay with it. They're like, yeah, that's totally fine. You can do that. Essentially, we have made it into a 1.7 ton unit and passed inspection and everything like that. So yeah, that was the solution we came up with there. Next slide. Right, so this is the heat pump water heater. One other thing I'll just say here is there's just like a bunch of parts and pieces of doing a heat pump water heater right. Making sure the venting, it's only producing cold air, but it is important that you don't kink that ductwork, that you route it nicely to, in this case we went to the existing sidewall vent that was previously where the flue gases went. We have a thermostatic mixing valve. We have our condensate piping. Condensate isn't something that a regular gas water heater produces, so figuring out how to get that out. We have been targeting primarily exterior water heater closets because it's so much easier to get that condensate out. Otherwise, you'd have to run it to a P-trap under a sink or something like that. And those are some of the highlights. And then, another thing you have to do is run an electrical circuit from the existing electrical panel over to that heat pump water heater closet, which is always an adventure, and we have some techniques for doing that. All right, I better keep moving. Okay, yeah, EV charging. Owner wasn't particularly interested in EV charging, but the EV charging incentives are generous in SMUD, and actually, we can, as a general contractor, put a whole project together that makes sense, but the EV charging helped to kind of subsidize a little bit of the heat pump water heater installation in SMUD, so that was useful. And there's not a lot of EVs at this senior housing facility, but there will be, and so, at the overall price to the customer is better by including EVs, so that's why they went for it. They weren't particularly hungry for the EVs themselves. And this has the loop charger model. There's no operating cost to owner. It's just a pay per charge. and at a lower price. Residents save, I think we estimated each resident driving a car would save $1,000, and then the owner just gets revenue. So it does create a win-win and no ongoing operating costs to ownership. These are being installed right now. The rest of the project has already been installed. Next slide. Heat pump pool and spa heaters. Those are in the midst of being installed now as well. I'm going to keep moving. Okay. Oh, good. Actually, we're doing all right on time. All right, changing gears to Sage Park, which is a property in Southern California, in Gardena. This is going to be more on the central side of things. So this is a 90-unit complex in 4 residential buildings, and then they have a community building as well. So this is kind of an aerial shot. So the water heaters are on first floor kind of sheds. Here, they're existing gas boilers. I guess a shed's not a good word. It's like a little enclosure with no roof. So it's an outdoor area. And then the electrical is on the opposite side of the building. And go to the next slide, please. Okay. So project financial summary. This is a $1.1 million project cost with $1.1 million in incentives, so $0 to the owner to implement the project. With about $3,100 a year in owner savings. Most of that comes from the LED lighting retrofit. Electrification doesn't actually save any money, usually in California, because electric prices are so high. So hopefully it's going to be a wash on that side. And then if you've got some LED lighting to sprinkle in with it, that can actually generate the savings. And that's where the tenant savings comes from as well. Next slide, please. This is a 4 incentive program stack. Low-income weatherization program brings $172,000. Tech, $171,000. Camera, which is LADWP, comprehensive affordable multifamily retrofit program. That has a prevailing wage electrical requirement and apprenticeship requirement as well. So the electrical work had to be prevailing wage on this. And then MAHAP, which is a South Coast Air Quality Management District program, they put together an electrification program as well. So it's almost like when we do these projects, where we stack all these incentives together, each of them has their own timeline, each of them has their own requirements, each of them is their own stakeholder, and we need to manage. It's like having 5 customers at once, kind of. So and move the project along and keep everyone apprised as we have the various things that come up during construction projects. So it's always an adventure, a lot of fun. Okay, next slide. So here's the scope of work. So we're doing 4 central heat pump water heaters where we remove the existing boilers and install CO2 heat pump water heater systems. This is a Sanco-based system. There's hard water here. Sacramento didn't have hard water, but here we do have hard water, which is a consideration because that can scale up and compromise the narrow flow pathways inside of a Sanco. A Sanco only has 1/2-inch flow pathways, so managing the water quality is always important. Variable speed recirculation pumps. New rooftop package units. We took out the gas package units that had air conditioning, converted those over to heat pump package rooftop units. That's actually not done yet. Will be done soon. The heat pump water heaters are installed. Smart thermostats and common area lighting to LED. Owner was super excited about that. Probably the #1 selling point of the project to them because they had older generation LEDs that were burning out. So again, this seems to be the thing that owners still are getting excited about, which is good, helps to make the project happen. And then on the in-unit side, aerators and shower heads, smart thermostats, and upgrading in-unit lighting to LED. Next slide, please. Okay, we'll go through the common area scope. Next slide, please. So yeah, here's the existing condition of hard water. So you can see, maybe some of you, at least in the middle, sorry to those of you on the wings, but there's got the copper pipe has this white kind of calcified appearance on the exterior, which can be indicative of that hard water that we see in a lot of Southern California, where they're, I spent the first part of my career in New York, and New York doesn't have this issue. New York City has lots of other issues, but not that one. And yeah, so hard water can be a real problem. This site was at 279 parts per million, 17 grains per ppm, so it's up at like 15, 20 grains of hardness. That will void any existing domestic hot water warranty. So, you talk to the facility staff and they'd already replaced most of the boilers, even though, in the past like 5 years, something like that, boilers weren't lasting very long because, hard water actually impacts gas boilers in some ways worse than heat pumps. It affects heat pumps too, but with gas boilers that calcium and other minerals that are dissolved into the water, when subjected to the heat of a flame, they precipitate out onto the area where the flame is up against the metal and then reduce the heat transfer. So the water can't take the heat away. And so then eventually you burn a hole in the metal because that metal gets overheated and kind of melts away. So you see this premature failure. And that's why most boiler manufacturers, once you get above 10 to 15 grains, they'll void their warranty. So a lot of owners don't know, like they have a voided warranty to begin with. Heat pumps also can be susceptible to scale, particularly the Sanco units we're installing here because they have half-inch connections, and it's a narrow flow pathway. So it doesn't take a whole lot of scale building up to start occluding that flow pathway. And that the good news is with heat pumps that it's more reversible. So it's important to either soften your water or put in a water conditioner if you can't do softening, which is what we did here, and get regular service on a heat pump water heater to do a food grade descaling so you can temporarily take the system offline for an hour, come once a year or so and flush it out, and then you can get rid of that scale buildup. Helps to keep the system operating well. Okay, next slide, please. So this is a picture of some of our installation work. It's kind of small and hard to see here, but here's a Sanco heat pump water heater. So we did 4 plants, 6 Sancos, 4 Sancos, and 3 Sancos, which we sized using a methodology very similar to what Elise described. We actually like SoCal Gas, I know those 2 words in a sentence are a little strange, for one reason more than PG&E, which is that their gas data is hourly, which is beautiful. So we can actually take the hourly gas data and analyze it and figure out how much recirc load we have, how much primary load we have by disaggregating that data and slicing and dicing it a bit. So we're able to zero in on a really good size. And we took some really creative 3-dimensional kind of work because this is like a roofless enclosure here, and just kind of the tanks are down low, and they have way oversized their existing piping. God, like the ASPE code on pipe sizing, I can't wait until it changes because you see like this is a 32-unit building with 4-inch cold and hot supply pipes, 4-inch, which is insane. I mean, they really they only need like 1.5 inches. I mean, and what does that mean? Like, it means the contractor who installed it, got to charge a lot more originally, back in the original building days. But it also means that then you have a much harder building to deal with because the pipes are so oversized, pi r squared. So if they have a 4-inch pipe, but they really only needed, say, 1.5 inches, you've got like 5x maybe the cross-sectional area, which means that your flow rate will be 1/5. So it just takes that much longer to get hot water out. And after we installed, we took some measurements on how long it was taking folks to get hot water to their unit, and it's like 2 minutes. That was the same as before it was installed. I mean, we went and we did the whole math on it. It's just ridiculous, like just so oversized. So I know the ASPE, I think it's coming out with Appendix M or something like that in the near future, where everything is going to go down in size. Because it's like we're still building buildings with pipe sizes as if there weren't low flow devices, like as if every faucet was running at 5 GPM when they're really running at 1. So it's looking forward to that because that'll help. But when we retrofit, we deal with all of the problems of yesteryear. So we get to have that fun. Okay, I think that, so here you've got primary storage tank. We've got a swing tank over here. And then the Sancos are kind of up above. So you can see those here and here. And then all kinds of creative piping. It's like our plumber is like a 3-dimensional artist figuring out how all of these things can wrap and weave and, all the different valves and manifolds that need to come together to make these systems work. Oh, okay, sure, thanks. All right, next slide. Right. So for the central heat pump water heaters, we included 3 years of biannual service in the upfront cost. So 2 site visits per year to check on the heat pump water heater performance and flushing and descaling of all the units, and then a 24-hour response time to issues. We had wanted to do a full water treatment system with salt ion system, but they don't have drains available. So we went with a water conditioning system, a halo ion system that just ionizes the water to try and reduce scale formation. Next slide. Variable speed recirculation pump. That's important because the real enemy of the efficiency of these systems is the electric swing tank, and the electric swing tank is dealing primarily with recirculation. So always what you want to do together with these systems is recirculation control, reduce the amount of recirculation load that you're putting onto that swing tank. So a variable speed recirculation pump is one side of that. And another thing that we do is we have some controls that we put into our systems to divert a little bit of recirculation flow to primary. You gotta, that gets pretty technical. You don't want to send full recirculation to primary because then it can cause your system to not have the ability to meet temperature. But if you just send over a little bit, it can still meet temperature, but you can get some big efficiency wins. So we have a few different irons in the fire in different systems where we're playing with either motorized valves or little bleed valves to send a small fraction of that recirculation return back to primary. Next slide. Rooftop unit replacement, that's more straightforward. Next slide. And I think that's it. So I have time for Q&A. Questions? Yeah, go ahead.
Yeah, so the project that you showed was in SMUD territory.
Yeah, the first one, Foothill Farms, yep.
So I'm curious about the payback period and the operational cost once you have this equipment installed for SMUD territory versus projects in PG&E territory.
Oh yeah, well SMUD is amazing. I mean, so the question is, what is the payback time on the Foothill Farms project, given that it's in Sacramento, in SMUD territory, versus the IOU territories? So I mean, the out-of-pocket was $27,000, and I think it had like a 3 or 5 year payback, somewhere in that range. But the bigger selling point with these, because electrification savings are so low relative to the cost, is we really need incentives to cover basically the entire capital cost. And what you're not seeing is all the projects that we looked at with these customers, you know, where that might not have been possible, because you can't just pick any building and get these incentives. You have to be in the right place, kind of, and the right time, and both of those things matter. But anyway, leaving that aside and coming to your question about SMUD, SMUD definitely helps in terms of the payback side because you actually can get savings from that switch from gas to electric. In this case, with unitary systems, most of those savings are going to the residents. So you know, there's that split where the resident is paying that bill. But SMUD at 13, 15 cents per kilowatt hour versus PG&E at 35 to 40 cents a kilowatt hour with the same gas prices, it's the paybacks in SMUD, heat pump water heaters actually can generate some dollar savings, which is nice, whereas in PG&E they don't. So I don't know exactly what the payback would have been. Probably lighting was driving most of the savings anyway, but it would have been a little bit longer in PG&E territory. Yeah. Yes.
On the first property, you had interior water closets and you were exhausting air outside. What is that doing to depressurization in the units?
It's a balcony closet. So the question is, what were we doing to depressure in terms of depressurizing the first project I showed with the individual water heaters in the closets? Those were balcony closets, and so they're accessed by exiting the residence unit and then stepping into that balcony, and then its sidewall ventilates out. So makeup air came in through the front door and then exited out the side. Now, if you are going to do that, you would depressurize the unit. So they're, I think, in the neighborhood of like 250 to 300 CFM that they can run at. It depends on how good your ducting pathway is. Can be a little bit lower than that. at times. But yeah, you do have to be mindful of that potential for depressurization. We try and either do, you take air from outside, run it through, and then put it back outside, or take air from inside, run it through, and put it back inside to avoid that issue.
No, that's what we, yeah.
But sometimes that may not be possible. I haven't been up against that yet. Yes, question.
You mentioned like replacing water fixtures with like low flow. I don't know if you do that for just faucets or maybe shower heads too. You know, you talked about not oversizing things, so you really need to match your production with the usage, right? What level of education do you need for the tenants? Do you get pushback? And I imagine you try to take as much out of the hands of the tenants as possible, where it's just kind of like it's the savings are built in, like with the fixtures and stuff. But what kind of education is required for people?
I mean, we do try and keep it to a minimum because we a lot of times people aren't home, and like we try and keep it simple so that there isn't, like with a new heat pump water heater and the new HVAC unit. Like at the end of the day, we'll have a one pager that we'll send in before and afterwards, kind of saying this is what we're going to do, this is what we did, this is how it affects you. But really, like life doesn't change for them all that much. I mean, when they want hot water, they open the tap and they get hot water. When they want it to be colder or warmer, they set the thermostat accordingly. We even left their original thermostat in place in this case. We talked about doing smart thermostats, but it was a senior community, and the people felt, no, we don't want to introduce them to new. So their user interface stayed actually exactly the same at the Foothill Farms property. And also at Sage Park. Like the individual experience of the residents, they'll be like, wow, it's brighter in here, I have new lights, but otherwise they're not really seeing much. Low flows, sometimes we get some complaints about, but we try not to push it too low. We stay at usually 1 GPM bathroom, 1.5 GPM kitchen, 1.5 GPM shower head, and I've done tens of thousands of units with that, and it's pretty safe territory. When you push down to another half GPM lower than that, a lot of times you start to get a lot of complaints, I found. So